Okay, so we are going to be looking at section 5.1.2, which is using a graph to find an inverse. So what we'll do is we'll do half of the section today, and then we'll do the other half on our next class, both of which will be asynchronous. So we're going to start with question 16. So it says, in lesson 5.1.1, you started with functions and worked backwards to find their inverse equations. So keep in mind we had kind of two different ways. One way was we wrote out all of the steps of the operations, and you could always work backwards and do the opposite. Another way was by solving it simply algebraically by following those steps where you switch x and y and solve for x. So now we're going to focus on functions and their inverses represented as graphs. So use what you discovered yesterday as a basis for answering the questions below. So we have three different types of functions. We have a line, a quadratic, and a cubic. So the first thing it says is to obtain a resource page. So you can click the link, obviously, but I also posted it on my website and on Google Classroom, so you can go ahead and just use that. You do not need to, but what they want us to do is sketch the original and the inverse. So I have the originals here. So we'll do the first one together. So we all should kind of realize at this point that the inverse is really just the opposite xy values, right? So if my ordered pair is 2, 1, then the inverse will be 1, 2. So I'm going to start sketching this inverse. So I have a point at negative 6, 0. So I know I'm going to have a point at 0, negative 6. I have a point at negative 4, 1, so I will have a point at 1, negative 4. And then I believe I made my first point wrong, so that's why. Okay. I have a point at 0, 3, so I'm going to have a point at 3, 0. I have a point at 2, 4, so I'll have a point at 4, 2. And then lastly, I have a point at, let's see, 6, 7, 8, and then 8, 7. So I'll have a point at 7, 8, which is up here. So here we have our inverse. So they want you to go ahead and do that for all of the graphs. So again, what we're doing is really just switching all of the x and y values. So I will let you guys go ahead and do the second and third graph. Now looking at the next question, it wants us to make statements about the relationship between the coordinates of a function and the coordinates of its inverse. Use xy tables of the functions and an inverse to show what you mean. So really, we already just talked about that, but the x and y values switch. And so the point xy in the function would become yx for its inverse. Okay. So again, you guys will go ahead and finish up the second and third graph if you haven't already. All right, moving on to question 17. So for question 17, it says, when you look at the graph of a function and its inverse, you can see a symmetrical relationship between the two graphs demonstrated by a line of symmetry. Draw the line of symmetry for each pair of graphs in problem 5-16. So I obviously only have my one graph, but you guys should have multiple. And you should notice that there is a line of symmetry, and it happens to be at the line y equals x. So if I reflect this across, I should get its inverse. So for part A, it wants us to tell, it says draw the line of symmetry. So I'm just going to say C graph because we already did that. Now for part B, it says find the equation of the line of symmetry. So the line of symmetry is y equals x. So what we just did is we found yet another way that we can graph it. And I will let you answer part C. It says, what do you think this line, or why do you think this line makes sense of for the line of symmetry between the graphs of a function and its inverse relation? So there's a couple different reasons. So I will have you guys answer that, and of course you can check your answer later on. But at this point, we should kind of feel comfortable. We know how to find an inverse algebraically. Now we know how to find it graphically. So we're going to go ahead and skip question 18 and move to question 19. So for question 19, it says your graphing calculator can help you to graph the inverse of a function. Check your inverse graph from problem 5-18 by the following teacher's instructions to use the inverse drawing feature of your graphing calculator. Was the inverse graph that you drew correct? Okay, so we're actually not going to use Desmos. I mean, obviously they have the graphs here, but I'm going to kind of talk through how you would do this on your graphing calculator. So what you'll want to do is you want to sketch the original. So I'm just using x squared. So I have my x squared. Now I'm going to kind of just talk through this. You obviously can't see what I'm doing. So I'll talk through this, and then if that was not enough for you, there will be an additional video of me videotaping my graphing calculator so you could actually see what I am pressing, okay? But hopefully just the talking through will be enough. So what you're going to do is you're going to go ahead and go to your graphing calculator. You'll click y equals, and for your equation, you're going to go ahead and put x squared. And remember, you can pause me at any time. And then you're also going to put a second equation that will be y equals x. So right now you should have two equations, one at y equals x squared and one at y equals x. From there, you're going to click second, which is at the top of your graphing calculator, and then program. So program's kind of in the top middle section. So it says PRGM, so second program, and then it's already selected on draw, so at the top. So what you're going to do is either scroll down to 8 or click the number 8, which says to draw the inverse. Okay, and then you're not going to click enter quite yet. So right now on your calculator, it should just say draw inverse. From there, you are going to find the button on your calculator that says vars. So vars is next to the clear button. So it's on the left of the clear button. So I'm going to click vars, and then I'm going to scroll to the right to y vars. From there, you should see that it says function. So I'm going to click enter. From there, it says y1, which we want because that's the function we want to draw the inverse of. And then from there, on your screen, it should say draw inverse y1, and I'm going to say enter. And then it will take you immediately to your graph, and you'll have your y equals x squared, you'll have your line of symmetry, and then it graphs your inverse. Now, some of you are probably thinking it looks a little bit like stretched out. That's just the way the scaling is on the graphing calculator, but what's great is now we have the table and now we have the picture. So what you'll do from here is just sketch your inverse. So again, if you were not able to get that or follow that, what I would recommend is watching the graphing calculator video after this. All right, so at this point, we have done 16, 17, we've skipped 18, we've done 19, and the last problem is question 20, which you guys will do on your own. So for question 20, it just says to find the equation of the inverse y equals x divided by 2 squared, or you can think of it as 1/2 x squared. Is there any other way you could write it? If so, show how the two equations are the same. Justify your inverse equation, or justify that your inverse equation undoes the original function, and use a graphing calculator to check the graphs. So that will be your last question. All right, so this was 5.1.2, day 1.